all know, data space are mentioned by the European Commission in the Digitalization of Energy Action Plan as one of the 5 pillars for the transformation of our energy system. And there are a lot of initiatives going on in all the different sectors. When you limit just at the energy, there is a cluster of projects funded by the European Commission as innovation action that are tackling this challenge. There is an overarching coordination support action called INTNet, which I have the pleasure to coordinate as part of my job in Fraunhofer. But still, there are a lot of challenges mostly related to semantic interoperability, which is considered as one of the critical hurdles. There are solutions in technologies. I would say one relevant technology are the so-called data space connectors. And this would be, I would say, one of the key discussion also for today to understand their role and their options. And the good thing is we have exemplary implementation, and we had the pleasure here to have an expert also specifically on this point with the presence from engineering of Ferdinando Bosco. And so we will have 2 parts in this discussion. First, we'll have 4 presentations for our speakers, and then we'll run together a panel discussion that I will coordinate. The speakers will be following the sequence. We'll have first a presentation from Daniel Alonso Roman, and then one from Sonia Jiménez Moreno, then Ferdinando Bosco, and last but not least, Christoph Lange-Bever. I will briefly introduce each of the speakers before their presentation. So before I give the floor to Daniel Alonso Roman, I would like to give a brief introduction about him. He's a senior technical lead at Big Data and AI ecosystem. His presentation will cover data space, fostering adoption and value generation. With over 25 years of experience in telecommunication and ICT, Daniel Roman has dedicated his career to research, innovation, and industry within this sector. He has played a significant role in key regional and European technology innovation systems, participating in forum discussion, organized strategic activity at event. And since 2003, he has been working at Big Data Value Association as senior technical lead for Big Data and AI systems. There, he focused on 3 main areas: leading activity to produce significant outcomes in data space, supporting the development of strategic agendas, and engaging with stakeholder networks at international, European, national, and regional level. With that, in the interest of time, I would like to give the floor. Please, Daniel, the floor is yours.
Thanks a lot, Antonello. I hope you can see my screen and hear me well. So thanks a lot for your kind introduction. Very much appreciated. You described my role very well, so fully aligned what we are doing here today. Because yes, I am representing BDVA, the Big Data Value Association, and yes, I have called my presentation Data Spaces, Fostering Adoption and Value Generation, because on the one hand, my idea is to provide kind of a framework or an umbrella, probably to what my colleagues will be presenting later on, but also because this is basically the mission from BDVA, to foster the adoption and also to foster and also create value generation out of data sharing and data spaces. So let me start my presentation with a few words about BDVA, our association. So BDVA was created in 2014 with the main objective, just to foster, as I mentioned before, data-driven innovation and experimentation in Europe. At that time, in 2014, we became the private counterpart of the Commission for the Big Data Value PPP, the Public-Private Partnership. But from this time, our association has evolved a lot with more than 2,050 members all around Europe, but also incorporating and extending our activities to more data-related technologies that can complement or enrich or benefit from the data perspective. For instance, we became also members of ADRA, Artificial Intelligence, Data and Robotics, and with ADRA, we also became the private counterpart of the Commission for the ADRA PPP. We are also members of the EuroHPC joint undertaking, which is together with the Commission to make accessible to researchers and industry in Europe high-performance infrastructure, computing infrastructure. We are also members of the Trust Computing Continuum, that involves other associations, for instance, 5G, cybersecurity, IoT, HPC, and so on, to provide this, let's say, seamless computing continuum. And we are also members of DSBA, Data Spaces and Business Alliance, that I will explain later on, which basically we are looking for convergence towards the adoption and implementation of data spaces. So in this sense, BDBA is playing this role as orchestrator or facilitator of collaboration, and we are at the core of this, as you can see, very rich ecosystems. But the work in BDBA is operationalized through our members, and our members are distributed in different task forces. So we organize the real work and the production of content and also deliverables and outcomes through different task forces. And you can see here in the picture all our task forces. So on the bottom part, you have the foundational task forces, but in the medium part, the yellow blocks, you can see our, let's say, more technical and cross-sectoral task forces. And most of them are working with the data spaces or elements or block of data spaces. For instance, we have a dedicated task force for data spaces. We have several task forces working on AI, so generative AI and foundation models, but also data and AI technologies. We have also task force around standards. We have task force around policy, societal and regulation, emerging topics, and also connection with HPC and the experimentation through the AI spaces. But we have also sectorial task forces, as you can see here, touching relevant sectors that we think are relevant for European economy and also very related to the data innovation. And among others, you can see here also energy, security, agri-food, media, telecom, healthcare, and so on. So this figure provides a whole picture of what BDBA is doing, and also the different activities, and also the different aspect of around data that we are touching on our activities. But now going to the point, data spaces, and probably my colleagues later on will have the opportunity to define with more detail data spaces, what a data space is. And you will find also in internet and also in different documents from the Commission and from others different definition of data spaces. But I have brought here the definition that we from DSCC, Data Spaces Support Center, where many of us actually are involved, the project we have included in our glossary, which says that data spaces are distributed structure defined by the governance framework that enables trustworthy data transaction between participants while supporting trust and data sovereignty. The data space is implemented by one or more infrastructures and supports one or more use cases. And I think this definition, in my opinion, summarizes pretty well for me the three pillars of data space. The one pillar is technical drivers to provide a connection between the participants and, of course, interoperability. The other pillar is trust. So participants have to trust each other. So data space has to provide the need mechanisms to provide this trust. And finally, is value. So data space has to be able to provide value to all the participants in the data space. So going with more detail, and again, I have brought this definition from the glossary of the Data Space Support Center, but probably the roles in the data space have a more variety of that. But at least this picture summarizes pretty well the different roles. We have on top of that the Data Space Governance Authority, which is basically who provide the rules of governance for data spaces, for data space, also provide the whole governance framework, and also the different policies that the participants has to fulfill. We have also the main pledges about data, which are the holder and providers on the one side, providing data, but also recipients and users on the other, making use of those data. And we have called data spaces intermediaries, which who provides data enabling services for data space, and those services that are needed for the data space to run and operate. Okay, so these are the different roles. And again, as I mentioned before, the key point here is to generate value. So we think it's very important to change the mindset of the participants from this point, don't share data unless it's completely necessary, to the other thing, which is share data unless restricted. So if we are able to change this mindset, we will see that there are different types of generating value out of data in data space. But at the end of the day, the value of data depends on the capacity of the participants to generate individual and collective value through different aspect use cases, but also from different individual perspectives. So different dimensions: business, innovation, social, cultural, ethical, and more. And for instance, in DSCC, Data Space Support Center Starter Kit, we include different examples of collaborative business patterns that are based on cost sharing, joint innovation, to strengthen market position and also to create common goods. Okay. At the end, as I mentioned before, these new business opportunities come from the fact that we shift from this traditional don't share data unless is necessary to the, let's say, more cooperative way, which is share data unless is completely restricted. Okay. So once we have said that, data spaces, we have to say that in BDBA, we have been working with data spaces for a long time, okay? It's true that we have a dedicated task force for data spaces, but it is also true that we have been working with the traditional value chain from the very beginning, but also incorporating the dimension of data sharing data spaces also a long time ago. In this regard, we have published different papers, and the first one, or at least one of the first one, is on 2000. It was published in 2019 with the title "Towards a European Data Sharing Space." Okay, and in this paper we reflect about the main challenges about the data sharing and data spaces, but also value from different perspectives, and also what can be achieved by different data spaces. And we published in 2020 an updated version of this paper, which we call Towards a European Governed Data Sharing Space. We incorporated the term governance for data space. And in this case, we included two things. On the one hand, we propose from our side a whole timeline for the adoption of data spaces that you can see in this figure in the bottom of my slide. And we propose different activities: convergence, standardization, experimentation, deployment, and awareness. And depending on the timeline, we devote more or less importance to different activities. For instance, for us, it's very important that from the very beginning, we focus, all of us, the different actors on the space in convergence, that we speak the same language, we combine the different technologies to reach this convergence, but also more and more creating awareness of data sharing and the value of data spaces. From the very beginning, it's also important to consider standardization. I will not go into detail, but probably most of us, the speakers here, we are involved in different activities on standardization. We're involved in different Sentinel workshops, but also joining technical committees to foster the standardization of data spaces, but also from the very beginning, experimentation. And once we have this convergence, again, more and more awareness, but also relying on the deployment of the real components of data spaces. And also my colleagues here will also talk about different blocks and deployments of data spaces. But at the same time, we included in our publication this what we have called the magic wheel to generate value out of data sharing and data spaces. And as you can see here at the center, we have trust. As I mentioned before, trust is key for all the participants in data space to share value in a reliable and effective environment. And around that, we have value, as you can see here. And as we will this round, you will see also data, technology, organization, people, and governance also as key aspect of the data space. And after those two papers, we have also another one paper that we are about to publish right now, which is about, and it is more related to the topic of today, which we have called data sharing spaces and interoperability. And here what we do is just to consider metadata as a key aspect for semantic interoperability, not only semantic, but at least semantic interoperability. So in this paper, we include the value perspective of interoperability using the wheel, as I mentioned before. We also address the technical perspective of interoperability, addressing the different facets: transport, syntactic, semantic, behavioral, and policy. We also study ecosystem and life cycle perspective, addressing the various agreement models to reach interoperability. And we also study the landscape, also how to integrate, for instance, existing solution coming from IDSA, FIWARE, Gaia-X, and others. So again, those papers are available in our webpage, and the last one will be published very soon also in our webpage. So coming back to the convergence as one of the main drivers to generate value, I would like to present, as I mentioned before, data spaces business alliance, because here one of the main purposes of this collaboration is real to reach convergence, as I mentioned before. So BDBA joined forces with FIWARE, IDSA, and Gaia-X in 2041, so a couple of years ago, with the main objective to accelerate business transformation in European data economy and drive the adoption of data spaces across Europe and beyond. Okay. I have to say that the four associations, we complement very well each other. So as you know, FIWARE is implementing open source component for data spaces. Gaia-X is more focused on the trusted and identity management, also with the clearinghouse and so on. And IDSA, as Sonia will explain later on, is more focused on the connector, data sovereignty, and also the connectivity of data sharing. And BDBA is about, as I mentioned before, about requirements, support, advice, and also fostering adoption and generating value. So all in all, the four associations complement very well each other. All in all, we are bringing together more than 1,000 key players, combining all our members, but also very important. All in all, we are also bringing together more than 90 hubs in 34 countries that at the end are also raising awareness of data spaces, of data sharing, and also are following our strategy to implement data spaces. And last but not least, we published also what we have called DSBA Technology Convergence paper that summarizes pretty well what we are doing from a technical perspective. Also, another initiative that I wanted to mention is the Data Space Support Center project, because it's very much related to the previous one, because the four associations are members in this project, but not only us. The project is coordinated by Fraunhofer, and the project started 1 year ago. So you have been running for 1 year. And the main objective of this project is to support and coordinate the different initiatives all around Europe building data spaces. So at the end of the day, this project is providing guidelines, recommendations. We are providing a set of tools and also blogs and so on to facilitate to other initiatives the design and building and deployment of data spaces. I will not go into detail on the different assets that we are creating, but we just published the first version of our blueprint, which is composed of the starter kit, building blocks, a conceptual model, a glossary, and also a collection of the standards. I included here the taxonomy of our building blocks. You can see here, the different building blocks that we have identified so far that can be used to build a data space. And we have differentiated between the green building blocks, which are the organizational and business building blocks, in 3 pillars: business, governance, and legal, touching upon the different aspect about business, how to create value through use cases, and also data products, as I mentioned before. The aspect about governance, and also the aspect about regulatory compliance and contractual framework. And also aligned to what I mentioned before, the three key pillars with the space. We have on the one hand data interoperability from different perspectives, semantic with the data models, syntactic and transport with the data chain. Another, we have also sovereignty and trust as a central pillar with identity management and policies and control. And we have also data value creation, which includes description, publication and discovery, and also marketplaces. So the project is going on, and many activities are running, and also many outputs has been produced. And it brings me to my last slide, which is my two last slides, which is the one is for us. I wanted to mention the priorities for BDBA, because those 5 priorities for the future are very much related to data spaces, as you will see later on. On the one hand, we are one of the main activities to empower European industries for a human-centric digital future. So basically to produce disruptive AI and data technologies. The second point is expanding data-driven ecosystem across sector and global value chains. So very much related also to data spaces. The third one is making data and AI innovation fit for emerging infrastructure and platforms. The fifth is sustainable data and AI. So everything about green data and AI. And finally, integrating innovation, ethics, and compliance. So those are our 5 big strategic themes, and to some extent, all of them are connected with data spaces. So it shows you the importance that we from BDBA give to data spaces. And yes, this brings me to my last slide, which is how we see the evolution of data spaces from now. So for us, there are 2 key points that are important. On the one hand is that data spaces has not to work on isolation, but to connect with each other. So different data spaces to connect with each other, but not only among data spaces, also to connect with other ecosystem that have data at the core of the value generation. For instance, platform marketplaces and catalogs, but also more important to connect with the AI communities, because more and more we see data spaces having value if we link data and all the content of data spaces to AI communities, producing systems and models. And in this way, we see that the real value of data spaces for AI comes from specific requirements that we think that we have to meet in data spaces, but also those requirements are at the same time added value for AI. And I have mentioned here just some of them that, again, I think from data spaces can provide real value to AI communities to generative AI and large language models. So let me just control environment, rules for governance, sovereignty and trust, ethics and trustworthiness, and also access to cloud computing infrastructure. And on top of that, we also see very important the concept of data quality, okay? Because data quality for data sharing, data spaces, but also for AI, act as a source of trust, a source of quality, accuracy, and reliability for AI models, and also to fit specific application purposes. So this is our view. I just wanted to finish just offering BDVA, as I mentioned before, as a facilitator, collaborator, orchestrator, and I hope to continue our collaboration with future meetings and also future activities. So thanks all for your time and your attention.
Thank you very much for your presentation. And according to the agenda, now we continue with the sequence of presentation, then we will get into the discussion. Next speaker, the agenda is Sonia Jiménez Moreno for the International Data Space Association. She's actually director for data space technology. Presentation title is The Data Space Protocol as Enabler for Technical Interoperability. A presentation also the position paper Interoperability Framework in Energy Data Space. Sonia Jiménez is Director of Data Space Technology at the International Data Space Association. Her expertise lies in certification, data space in the energy domain, and personal data spaces. Among her current responsibilities, she oversees the IDS certification, serves as the product owner of the IDS reference testbed, and leads the IDSA Energy Interoperability Task Force. Sonia holds a bachelor's degree in business administration and a master's degree in marketing management, and a professional certificate in coding, specializing in full stack development with MERN. With that, I would like to give the floor to Sonia for her presentation. Thank you.
Thank you. Thanks a lot, Professor Monti. And thank you, Alice, for inviting me to present today. Okay, I will share my screen. Okay, I guess you can see my screen. Yeah, okay, perfect. So yes, I'm going to present the data space protocol and also the position paper focusing on interoperability framework in energy data spaces. So as you can tell, my presentation is going to be around the topic of the very important topic of interoperability. So let us start. And yeah, I'm really thankful also to Daniel, because I think he made a great introduction to the concept of data spaces. So that will make my presentation a bit easier. Brief introduction of the International Data Spaces Association. For those of you who don't know us, so we are a coalition of more than 140 companies, actually close to 150 now, that share a vision of a world where companies realize the full value of their data in secure, trusted, and equal partnerships. We are a non-for-profit organization, and all members contribute equally to the association results. Everything we develop, everything we produce, we do it together with our members, and we always share it. So we make it publicly available so that the whole community can benefit from all this material. And then some assets that we have. So we develop a reference architecture, the reference architecture model that we are known for. That's the blueprint for the creation of data spaces. We evolve IDS-based use cases. We aim to establish the IDS as international standard for exchange in the economy of the future. We support the certification of IDS-based software solutions, and then we shape the future of IDS with open source. Here you have a picture of some of the logos that are from the members of the IDSA and all the people that are contributing and the number of countries. So we are really an international association, having members in 5 continents. Here you can see the 3 main pillars of the IDSA. Daniel already mentioned them. So on the left-hand side, we have interoperability. So in order for data spaces to evolve, to flourish, and to proliferate, we need to ensure interoperability. So we'll be focusing on this part in my presentation today. Trust is also key. So we need to make sure the participants of the data space can be trusted, and also the systems that they use to share their data can be trusted. For this, we have defined the certification scheme to certify both the organizational environments of the participants that participate in the data space, and also the software components that they use, so like our connectors to send and receive data. And then on the right-hand side, we have the concept of usage control and enforcement for data flows. This means that the data owners, or the ones that send the data, is always in control of what can be done to with his or her data and what happens to it. So focusing on the topic of interoperability, we've used here this new European interoperability framework to depict these 4 different layers for interoperability. Starting at the bottom, we have the technical level and the semantic level. For the technical level, this is about, only from a technical perspective, how to ensure that the different connectors or different participants that use a connector in the data space can communicate with each other. And one of the things we've developed to achieve technical interoperability is the data space protocol that I will explain today. We have the semantic level. I will not go in deep into here because we have a presentation about that, but I will only mention that both technical and semantic level are responsibility of the participant. So they need to make sure they can achieve this type of interoperability to participate in the data space. The 2 upper layers, those are the organizational and legal levels. So here we are talking about business procedures, what rules are established in the data space, also legal agreements. In this sense, we cover these topics from our side in the IDSA rulebook. And also we have a task force, the IDSA legal task force, that deals with all the legal aspects of data spaces. So this would be like an overview of all of the things that need to be taken into consideration when creating or when participating in data spaces. As I said, today I will focus on the technical level, but it's important to bear in mind that it is not only about ensuring technical interoperability in the data space. And then the 2 upper layers, so the organizational and legal levels, they need to be provided or ensured by the data space rather than by the participants. Continuing with the topic of technical interoperability, we have also to take into consideration that we have here 2 types. One is the intra-data space interoperability. That means the interoperability within a single data space instance. So that's between the data space authority and the participants of the data space, so all the data sharing building blocks, but again, within one single data space instance. Then we have the inter-data space interoperability. And this is when we want to make sure 2 data spaces instances, 2 or more, have to be interoperable. And this is, of course, this picture shows it very clearly, very easily, but of course, this is complicated. There are many things that need to be taken into consideration, and many agreements that both data spaces instances need to achieve. So focusing on technical interoperability, and one of the assets I mentioned that we've developed to achieve this technical interoperability, I'll explain now the data space protocol. So the data space protocol is what is the specifications that make sure that this technical interoperability between the participants of the data space or all the components of the data space is possible. So it's the set of schemas and protocols required to publish data, negotiate usage agreements, and access data. And what's big change in this data space protocol is this separation of the control plane and the data plane. On the control plane is where the policies are negotiated. So the contracts are negotiated and the policies are defined. And then the data plane is where the actual data transfer takes place. So they are conceptually divided, and for some reasons that I will explain now. So this has some benefits, but practically they can be combined. So why are we separating these two layers, the control plane and data plane? Here you see some of the benefits. So first one is flexibility, because you separate the decision making from the action taken. So you can always say, okay, I agree on the control mechanism, so the control plane, but then the actual data transfer can happen with different data transfer protocols. Okay, without changing these control mechanisms. Scalability. So with this distinction, it's easier to scale each plane independently. So independently from each other, depending on the needs of the specific use case. Then security, because we have this separation of roles. So the control plane focuses on secure and trusted data exchange, and the data plane focuses on the efficient data transfer. And then modularity, because as I said, you can change one of the planes without affecting the other. Then taking a look into the protocol structure. So it consists of 3 layers: the catalog protocol, the contract negotiation protocol, and the transfer process protocol. So the catalog protocol is for the data provider to set this list or this catalog showing their offering, showing the data that they have, so that the data consumer can see this list. Of course, the data consumer needs to be authorized to see this list from the data provider. Okay? And the data provider needs to make sure that this list is organized in a standardized way, to make it easier for the data consumer to understand what type of data is available and how it's classified. Okay, and then only, as I said, only authorized data consumers are allowed to find this list. Then we move to the contract negotiation protocol. This is the steps, or this covers the steps that take place in a negotiation. So both parties have their conditions, and there are some messages back and forth to make sure these conditions are accepted. So, and once they've agreed on this contract, we move to the transfer process protocol, and this is where the data is transferred. Okay, so we have these 3 stages from data provider creates this list with their offering, data provider and consumer negotiate and agree on a contract, and once this contract is agreed, then the transfer of the data transferring actually happens. You can find the data space protocol on GitHub and on Gitbook. So there are publicly available repositories that anyone can take a look at, and also you can contribute to them. The data space protocol is currently in version 0.8, but once the current issues are solved, it will be published as a first version. As I said, and anyone can take, but it's already available for implementation and testing purposes. So anyone can take a look and test it. Okay. And then I will move to my second presentation. This is the interoperability framework in energy data spaces position paper presentation. So the purpose of this paper is to define a framework for achieving technical and semantic interoperability between data spaces in the energy domain. So the reason why we decided to write this paper is because the projects in this Horizon Cluster 5 call, they have the mandate to becoming interoperable. And we said, okay, let's sit down and define what that means and how we achieve this. And this document also can serve as a reference document for upcoming projects in the energy domain. These are the projects that contributed to or are contributing to the paper. So we have INNET as the CSA, and then NSHare, Omega X, Synergies, EDI, and DataCellar as the 5 sister projects. And the main contributors to the paper are the project's coordinators and technical coordinators, also semantic and technical interoperability task contributors from each project, standardization task leaders, and also the pilots coordinators. And what we did is we created a task force that's run by the IDSA back in March, and we defined what would be the topics that we would need to focus on to describe the interoperability. The first version of the paper, first draft version, was published a month ago. You can find it already on our website. And here you can see the table of content. So we give an introduction of the energy domain. What are the challenges that this domain have? Then we take a look into the state of the art, existing papers and standards. We explain data space governance and interoperability, but we really focus on technical and semantic interoperability. We show the reference architecture of the 5 projects, what they have developed until now. And then some tools and methods, and also we briefly describe how to achieve cross-domain interoperability. The work is structured according, again, to the new European interoperability framework, and it's based on the work of the International Data Space Association, Firewall Guidelines, and also the blueprint from the Data Spaces Support Center. Here you have some of the findings from the paper. So what's special about the energy domain that may be different from other domains? So we know the energy domain is in the transition towards digitalization and renewable energies, the role of electrification and the other sources that are being replaced by electrification now. It's a highly regulated sector, and this has an influence on the setup of the data space, the governance models, and all the policies and rules that are defined within the data space. So key findings from the paper, the relevance of the standards, and we have a full chapter referring to the existing standards and the need for standards, and also both technical interoperability and semantic interoperability. So what we need to enable this interoperability among data spaces in the energy domain. So what's relevant, what building blocks are relevant. Here I will not go into detail, but we've analyzed these existing standards. As you can see, there's a variety of standards from communication protocols and data models, interoperability of energy management systems, common language protocols, and security requirements. In the technical interoperability, we've defined which building blocks we have to take care of or we have to align among the different projects to achieve interoperability, which are the main actors, data formats and data transmission protocols, and then some challenges that we are facing. So starting by the use of different connectors by the projects, or the different implementations of the federation services, and the trust certificates that the different data spaces are using. So we have to make sure those trust certificates can be accepted in all of the data spaces, or that the same ones are used. Semantic interoperability, we also have a chapter on that. But here you see some of the key findings or the challenges. So we know the energy involves heterogeneous components and devices, and we have the need to establish or define common information models, like some of the projects have established already. Okay, and then regarding the next steps, we recently published the first draft of the paper. It's available, and anyone can also contribute and give us feedback. So feedback is very much welcome. We are reviewing now this draft, and we until the end of this month, and we plan to publish version 1 in end of November or beginning of December. We will present the paper at ENDIT Europe in Paris. We are working already on the second iteration, so we need to see what content we add to the paper. So the current developments of the technical and semantic interoperability of the projects. Also describe a system use case to demonstrate interoperability among sister projects. And currently we are aligning the architecture. So we will document how this alignment is happening and which progress we have made. And we plan to present the second version to the European Commission in probably in February, and even that still has to be confirmed. Okay, and that would be it from my side. So thank you very much.
Thank you for the presentation. Very, very interesting. And let me now move to the next speaker. We have now the pleasure to host Ferdinando Bosco from engineering. He's a technical manager in research and innovation. His presentation title is Energy Data Space Connector, a data space enabler for digitalization of energy system. Ferdinando graduated in computer engineering at the University of Palermo in Italy in 2012. Since 2012, he has been working as solution architect and technical manager in engineering informatica, research and innovation department. He has participated in many European research projects in energy domain, and in the recent years has mainly specialized in blockchain technology, distributed architecture design, and data space. Ferdinando, the floor is yours.
Thank you, Antonello. Thank you, everyone, for this opportunity. So let me share my screen. Okay. So I will present today this energy data space connector. So I will take into account, let's say, the technological part of the data space, that is our topic in this presentation, and how the data space technology can support the digitalization of the energy system. So focusing into the energy domain. So let me briefly introduce engineering. I think most of you already know us. We are the largest Italian tech company, and we support our customer into the digital transformation using business, technology, and managed services in order to accelerate the innovation and promote the sustainability. And engineering has several departments and business units. Of course, one of them is the smart energy utilities, in which my research and innovation department is part. And we realize any kind of digital transformation from our customer into the smart energy utilities domain, like technology, integration of solution, and also proposing our proprietary solution. But now I would like to go into the topic of today. So why we need to digitalize the energy sector? I think it's one of the main challenges that we discussed a lot of time in this period. And digitalization of energy sector needs high level of operational excellence and the usage of new innovative technologies in order to foster the cross-domain data sharing and the data-driven innovation. So the data exchange, the data economy is on top of the digital transformation of the energy sector. There are a lot of key elements in the data management in order to support this data economy in the energy sector. For example, data models and semantic. We need to define appropriate data model as an ingredient for the interoperability. We need to border the context information. So we need to find the gap between the different verticals, and in particular for the energy sector. Of course, we need to take into account the data sovereignty. So the ability of a data owner to define the usage and policy of the data, of its own data with third party. And of course, we need to have standardized interface like OpenAPI in order to create a real open competitive market, because closed solutions are not ready for introduce the new digitalization of the sector without creating this openness among all the existing solutions. So at the moment, from a technological perspective, we have some lacks, some missing parts that can affect this process. For example, we need standards about IoT protocols, interoperability, and integration. We need also to address very well data ownership and data security. We need also to avoid the limitation of the usability and interoperability of the existing application, because we have a lot of closed legacy applications that are not open and not reusable. And we need also to implement some cost-effective solution. What is the data-driven approach? What is a data ecosystem? The data ecosystem should enable the collaboration and cooperation. I think there are two important keywords among diverse and interconnected participants. These participants need to collaborate and cooperate each other for finding mutual benefit, and they should be supported by a trusted and secure data sharing. This is the main goal of the data-driven approach. How the data-driven approach and data space in this case can solve or facilitate the energy transition and the digital transformation of the energy sector. For example, in the integration of renewable energy sources, can facilitate the coordination of the renewable energy generation, storage, and consumption. In terms of demand response and energy efficiency, can enable the energy provider to collect and analyze information about, for example, energy consumption, demand fluctuation, customer behavior. Also for the grid management and network operation, the data exchange play a key role in this particular topic, because real-time data can be useful for new innovative services in terms of power generation, transmission, distribution among various stakeholders. Of course, market operation, because the market participants include several stakeholders that need to access data from different data sources. So we need to implement an efficient data exchange for implemented market operation and trading. And last but not least, the asset management, in which stakeholders can collaboratively optimize the maintenance and the management of the energy side assets, exchanging data. So all these use cases and scenarios can be solved or facilitated approaching the data-driven and the data space. We try to explain the data space to the energy stakeholder in a very simple way. And we try to define the data space like an ecosystem in which stakeholders can share and access data, ensuring at the same time data protection, data privacy in compliance with the relevant regulation. So this is a very short description of the data space. It's not complete, of course, but it tries to introduce the energy stakeholder in this concept in order to make them aware about the need of a data space and the data exchange in their ecosystem. From a technical perspective, we try also to identify some technological building blocks to be implemented for enabling the data space from a technical perspective. And these building blocks, of course, includes the data storage and the access control. So where the data are stored and how any data provider can manage the access on the data. Of course, the data exchange and the integration of the data itself. So how the data is exchanged among different stakeholders and how we integrate the components that exchange the data. Of course, we need to keep and ensure the data privacy and security during the data exchange. And it's crucial to implement interoperability mechanisms and standard data model and data format for ensuring the compatibility and the compliance of the existing system into the data space. So in order to implement something concrete, a technology that can help to implement or to participate in a data space, we started from the True Connector. The True Connector is implemented as open source in the Research and Innovation Department in Engineering. And it's a connector compliant with the IDS, so the International Data Space Ecosystem. The main goal of the True Connector is to enable the trusted data exchange as part of the IDS ecosystem in a virtual data space, leveraging in standard and technology, as well as governance models in the data economy, and facilitate the secure and standardized data exchange. The connector is compliant with the latest IDS specification and can be customized and configured to fit any kind of scenario. And we will see later how we customize the true connector in the energy sector. Of course, it can be integrated with a lot of other IDS services, and it's completely configurable in terms of data format and communication protocol and so on. This is the high-level architecture of the true connector. As you can see, we have 4 main components included in the architecture. Of course, there is the IDS-based execution core container that contains all the processes and the action needed for implementing the data space following the IDS guideline. We also have a configurable data application that is the entry point for the data exchange, so in order to provide and consume data. We also integrated the open source cloud authorized clearinghouse that is available using the true connector, and a usage control application based on one implemented in one of the projects in which the true connector was used, the Platoon project. So the true connector is the starting solution, as I said before. It's completely general purposing. It's not, let's say, contextualized in any sector. What we have done in the OneNet project is to take the true connector and create a new version of the true connector focusing on the energy sector. So we have done a technological maturation. We included IDS specification together with the FEIN smart energy architecture in order to converge the two ecosystems. And we introduced and integrated the FEIN context broker in the connector architecture. We also introduced new additional data services, for example, for data quality or data normalization or other data-driven services. For example, we have introduced a tool for mapping the data format from the CIM data model from XML to JSON LD and vice versa. We also created a layer upon the connector in which we implement a standardized API for the energy data. And we created around the connector a graphical user interface for facilitating the connector usage by the OneNet participant. On the right side, you can see the high-level architecture of the OneNet connector. So the OneNet connector is plug and play, deployable into the OneNet participant ecosystem. And the OneNet participant can act as a data provider or consumer using the graphical user interface or the standardized API. Another important step that we add into OneNet project is to focus and tailoring the connector for the energy domain in terms of standardized data format and data model. So what we have done, it's a deeper analysis on the existing project and existing standard and interfaces in order to identify which kind of services can be served into a data space ecosystem using the connector. We identify 10 different service categories. We will see later which kind of categories and services we defined, with 64 energy services. For each of these services, we defined which kind of data models can be used for that and which are the actors involved and the business object exchanged in these services. In this way, we facilitated the creation of data exchange into the OneNet connector using standard and interoperable mechanism for the integration. So as I said before, we converged 2 different worlds in the OneNet connector. The first is the FEIN ecosystem, so taking into account the smart energy architecture in terms of context broker for the data exchange, and of course NGSI LD for the standardized format of the data exchange itself. And from the other side, of course, we follow the IDS specification already implemented in the true connector. So we created this OneNet connector that it's part of both, in which we have the FEIN ecosystem, including the context broker and the FEIN data application, also compatible with the NGSI LD standard. We have the IDSA part that include the execution core container, the clearinghouse, the usage control application. And we have also additional data services, as I said before, implemented in OneNet. Again, the standardization in the energy domain was crucial because we converted a general purpose connector into an energy connector. We identified 10 different categories that can be grouped, in which the 64 energy services can be grouped. And for all these categories, we identified these 64 services. And for each of them, we standardized the method, the data actors involved, so producer and consumer, mapped in the harmonized energy role model. So with all the role in the energy ecosystem, so system operator, flexibility provider, and so on. We identified which kind of business objects are exchanged during these services that we named cross-platform services, which are the minimum data quality requirements for each data exchange, and which are the standard data format and data models. In addition, in order to simplify the integration and the deployment of the connector, we also provided to the OneNet participants the graphical user interface that allow to create new services based on the 64 cross-platform services that we identified. When a OneNet participant creates a new service, is able to define its own data model and data format, so a customized one, or in order to facilitate the creation of services and the data exchange, we propose the standardized data models that we identify together with the data profile. So for example, the CIM data profile for each of these cross-platform services. After the creation of the services, we introduce the new data sources in the data catalog, and any OneNet participant is able to retrieve from the data catalog the different data sources, create, request an agreement, so the contract negotiation for retrieving the data, and is available to consume the data coming from the services in a standardized or not way. In the OneNet project, I think we had also very important validation of the connector. Since the OneNet project is a very big project with the main focus to create this peer-to-peer fully decentralized ecosystem. And the main goal followed the creation of the OneNet network of platform. So a unique network, the one network for the pan-European energy ecosystem. And in the project, we had 10 countries for the demonstration of the OneNet connector, grouped in 4 different European clusters. So we divided our demos in 4 clusters: Northern, Western, Eastern, and Southern. And inside this cluster, we have 21 different use case applications of the connector and 4 cross-country applications. So 21 in each country, and then 4 that connect different countries. So we have data exchange among different countries like Greece and Cyprus, for example. So the advantages of the OneNet connector in terms of usability and also applicability in the energy sector, it's open to any kind of energy stakeholder because we have tested it with any kind of energy stakeholder like system operator, flexibility provider, market operator, and so on. We implemented some standardized process and data format and data models that can be followed during the creation of data services. We implemented a one-to-one secure data exchange. So there is no any data exchange outside of the 2 entry points, so the data consumer and the data provider. And we also facilitate the integration, implementing a graphical user interface and standardized open API for the deployment of the connector itself. But we are continuing our work. So we are creating the energy data space connector that is an evolution of the True Connector and the OneNet connector in the energy domain, because we are evolving it in many projects at the moment, including EnerShare, Flow, and Interstore. And our roadmap includes many extensions. For example, we are addressing the data-driven market for electric vehicle in Flow. We are also addressing the decentralized management of heterogeneous storage resources in Interstore. We are also implementing the blockchain technology for access management and login transaction. And we are introducing new technologies and protocols for the integration of the data. For example, we are implementing the integration of the IEEE 2030.5. And it's all from my side. Thank you, everyone.
And thank you very much, Ferdinando, for your contribution. Let me now just move to our last but not least speaker. Before then, we open the panel session. And our last speaker is Christoph Lange-Bever, which is actually also my colleague within Fraunhofer FIT. He's head of data science and artificial intelligence within Fraunhofer FIT. He will talk about semantic operability in data space. Christoph leads the data science and artificial intelligence department in Fraunhofer FIT, and he's also a senior researcher at WTH Aachen. He joined Fraunhofer in 2014 and the university in 2019. He earned his PhD in computer science from Jacobs University in Bremen in 2011, focusing on integrating semantic web for collaboration in mathematical knowledge. His research spans knowledge engineering and data infrastructure, emphasizing scalable, expressive domain knowledge representation and adherence to linked data and FAIR principles. His work enables enhanced machine support in various processes like data sharing and analysis, and finds application in enterprise information integration, research infrastructure, and cross-organization data space. He has collaborated with leading German international companies, particularly in the automotive sector. Lange is also active in the academic community, organizing events, mentoring PhD students, teaching, and contributing to international standards in semantic web and intelligent computer mathematics. Christoph, the floor is yours.
And thank you very much for this introduction. So I think you can see my slides. Well, I will now focus on the aspect of semantic interoperability in data spaces, reflecting on some of the insights I've gained from participating in multiple of the data space initiatives that have also been introduced by the previous speakers. Parts of this presentation are based on material I've collaborated on with one of our senior PhD students, Johannes Tyson-Lipp, whose PhD thesis, hopefully to be submitted next year, will have the title Semantic Foundations of Data Spaces. So quite close to today's topic. Let's see. So this is something that's my this colleague of mine prepared as an inspiration. So, well, what does it look like when semantics returns into data spaces? So he gave some creative prompts to AI image generators, and let's see who is who here. Like what is the force we need to use to make data spaces more interoperable and more intelligent? Let us hope that it is semantic technologies, and let's see to what extent this has been understood and has been practiced already, and what challenges are still open. Let's go straight into the topic. Well, data spaces in practical application, they've been around for a few years. For example, the very first steps towards the IDS international data spaces were made in 2014 in Germany before it was branded as an international initiative. But long before that, in the scientific community, there have been early ideas, which have in common with today's practical approaches that it was in contrast to centralized databases, keeping data at the source in heterogeneous formats as it is, and providing services in these data spaces, services on top of the data. And when you look at such an early diagram, you see a lot of well, standards and languages like web service description language and so on. So languages into which you can encode semantics. So that some of these ideas have survived. And there are, of course, more recent discourses on design principles for data spaces. So, for example, the linked data principles by the World Wide Web Consortium, but also the FAIR data principles to have data findable, accessible, interoperable, and reusable, which originated from the research data management communities. They are increasingly adopted also by industry-driven data space initiatives. And in the IDS reference architecture model, there has always been a box called a vocabulary provider. So an actor in a data space who provides the other participants in the data space with agreed upon vocabularies, or also called ontologies. And now, more recently, this has been filled with more life, and like software implementing this functionality is also increasingly becoming available. And then there are these overarching efforts that have been mentioned before, like here a white paper by the OpenDEI project on design principles for data spaces, which can be understood as the predecessor of the Data Space Support Center's blueprint for data spaces, which was already introduced today. What was also introduced by Sonia was the data space protocol, which is being specified by the International Data Spaces Association. So I will not repeat what it is and how it works, but I would like to emphasize that it is based on standards by the W3C, the World Wide Web Consortium, including the Data Catalog Vocabulary DCAT, to describe data that is being offered in data spaces, and the Open Digital Rights Language, ODRL, to describe in a machine comprehensible way what usage policies are attached to data. This here on this slide is a more dynamic view on like how the actors in a data space interact by speaking this protocol. The more static view on how data and metadata is represented is given by the by the IDS information model. And again, you see when you look at this hexagon figure of all the concerns of data exchange that it addresses, from content to what concepts are described, what is the community of trusted actors in which data is exchanged, what aspects of data as a commodity are we considering, how does the communication about data work? So, for example, in other words, how are we implementing the data space protocol, and in what context do the data have to be interpreted? All this metadata vocabulary for talking about all these aspects, all these concerns of data, these are all based on again on standards for semantic interoperability, which you see well hinted at in the gray boxes here in this diagram. And what's also in concern when describing data in data spaces is to be open towards domain-specific extensions. So in those who are familiar with the data catalog vocabulary DCAT, they may have heard the buzzword DCAT AP, where AP stands for application profile. Application profiling is a general mechanism by which like a generic interoperability standard provides extension points on how the standard can be constrained or extended for applications in specific domains or to specific use cases. The related Gaia X initiative adds another aspect to this. So there it is also in a very similar way considered how data or service providers describe their offerings using semantic metadata. But another aspect that is added on top here is the trustability. Not to say that IDS or the other initiatives have no trust. They also have concepts of like providing actors with trustable identities and certification. There are certification schemes in place and so on. It's just the way in which Gaia X provides trust is a specific one that is finely intertwined with semantics, because in Gaia X, data and service providers, they do not only claim what characteristics their services have, but they get these claims signed by conformity assessment bodies, and thus these claims become credentials. So what is actually exchanged is not just self-assessed metadata records, but cryptographically signed verifiable credentials. So basically semantics with semantic metadata with third-party confirmation. Let's look at briefly at Gaia X at further data space initiatives out there. So as I said, Gaia X has quite similar conceptual foundations to IDS. Regarding what is provided and what is consumed, it takes a different perspective. It focuses on services rather on data. However, in reality, most of these services do provide data. But there is also the aspect of looking at infrastructure as a service, like compute, storage, and network infrastructure that is also exchanged and traded in Gaia X. And well, quite similar to IDS, there is also a strong emphasis on what enabling services. In Gaia X, they are called federation services. What services are needed to enable, to operate a data infrastructure, and for this, multiple technology stacks have been implemented. And well, there is a number of Lighthouse and other projects that is starting to adopt this technology already. Then there are parallels to research data infrastructures. As I already said, the fair data principles come from that area. The European Commission says that the European Open Science Cloud, EOSC, should be regarded as a data space for science. Say by its mission and vision and ambitions, this makes sense. Technically, there is still some alignment that is required. Such an alignment effort is also going on in Germany, of which I am the coordinator. That is a project called Fair Data Spaces that aims at aligning on a technical, but also on a legal and community building level, the German National Research Data Infrastructure, NFDI, with the industry-driven data space initiatives, Gaia X and IDS. And there are further initiatives, also one by the creator of the World Wide Web and of its semantic web extensions, that's called SOLID, social link data. Now, what is worth noting is that all of these efforts, they agree to using semantic technologies for interoperability to some extent. Let's see to what extent. Those who are more familiar with semantic web technologies, they have seen like technology stacked as a layered cake like this. This is an unofficial interpretation by someone who has a lot of knowledge on the domain. This is more up to date than earlier versions that you see. So basically, the technology goes all the way up from like document and data formats to identifiers for things, to languages to talk to express claims in, to query languages, logic, dictionaries of terms like vocabularies, ontologies, and so on, and ultimately means of building trust. It is still challenging to adopt these technologies to the full extent in data spaces. For example, with the identification of data and with a good understanding of the fair data principles also comes the idea that things that have been identified should be permanently accessible through their identifier. This is not, in many data spaces, this is not actually the case. So data also become unavailable there. So links are not always dereferenceable, but go out of service. That is something that on the web in general is also being observed, but it makes data management and data reusability harder, obviously. There is, on the positive side, a lot of sharing of vocabularies and standards, and a good understanding that that semantic standards are essential. Like, for example, the recent IDS reference architecture model version 4 has put a much stronger emphasis on the role of the vocabulary hub in data spaces. There is also in the area of federation services for Gaia X. There is one in which I've had a strong participation. One implementation of a federated catalog for Gaia X, like a system in which providers list their data and service offerings. Our implementation has a strong emphasis on supporting extensible metadata schemas. But there are still limitations in adoption, so that many data space developers and users are not familiar with semantic web solutions. Keywords such as JSON LD, they are used a lot, but there is a limited understanding of what the LD in JSON LD means. It means linked data, and that technically that means a lot more. There is also, especially in European communities, the buzzword DCAT AP is used a lot, but it is understood only to a limited extent in the wild what the application profile mechanism abbreviated by AP, what that really stands for and how you can exploit it to use domain-specific semantics in your data space. Also, the inner content of data is not necessarily fair. And so overall, there is not yet as much intelligence in data spaces as there could be. There is a lot in progress. There are a lot of ways. I will share the slides later. There are a lot of ways for you to get involved. For example, I will skip over the initiatives that have been mentioned already. For example, there is the European Semantic Interoperability Community, SEMIC, which recently had a conference. So a lot of video recordings are available and a lot of webinars will be offered in the near future. And there is, on the more academic side, is a workshop series on semantics in data spaces that my colleagues have initiated. We are currently preparing next year's edition of that. So to conclude, data spaces are important for data sovereignty in Europe and beyond. In academia, the understanding has been around for a long time, keeping data at the source, also including semantics, sharing the data in a sovereign way. This is also what's practiced in the industry. There is an agreement on some use of semantics, but it could be more. The main focus in the industry-driven initiatives has so far been data discovery, data exchange, and how to establish trust. Semantics guarantees a common understanding through metadata and standards. However, in the broad user base of data spaces, semantic solutions are not yet fully utilized. On the other hand, this would enable a great potential for artificial intelligence. So compositions of smart services, or using AI assistants to find your way through a data space, or to automatically generate descriptions of the data you would like to offer. And with that, I would like to conclude and looking forward to the discussion.
Oh, very good. Thank you, Christoph, and thank all the speakers for the very, very interesting insights that we got through this set of presentation. Now I would like to start the second part of our meeting, which will be an open discussion. I would propose the following. I have quite a good list of questions myself, but will encourage people to participate. So best option will be that maybe you place your question in the chat, and then I will take care to forward your question to our speakers. Let me start with a kind of a broad question, and I'm not directing any of you directly, so who wants to answer is welcome. So we get a very, very nice and complete picture of the situation. I'm mostly involved in this exercise within the energy sector. My main curiosity will be, if we compare the situation in the energy sector data space with other sectors, what is your impression? Is energy on the right track? Is having the right pace, or are we not satisfied with what's going on in energy compared to other sectors? I don't know who would like to.
Maybe I can start.
Thank you. Well,
okay, from a purely data space perspective, what I say, I think energy is a trendsetter when it comes to interoperability. So the fact that now these 5 sister projects that started a year and a half ago have to become interoperable, I think that's new. I'm not aware of any other data spaces in other domains that have this requirement. So until now, we've really focused on the intra data space interoperability, but now we are testing, or we are defining what it means to achieve this inter data space interoperability. And this is really not simple, because as I explained, we have different layers of interoperability. And what's the requirement? So is the requirement that it is technically possible to connect to data spaces, technically possible for a participant of data space A to participate in data space B? Or is there anything else on top? Do we have to talk at the level of data spaces authorities, or both data spaces agreeing on certain procedures, rules? Yeah, also in terms of the decisions around the architecture of the data spaces. So those are the things that we are defining now within these 5 sister projects. So I think this will set an example also for other domains.
okay, that's very promising feedback. Thank you. Any other comments? Daniel, please.
Yes, thanks a lot. Sonia introduced very well the topic. Well, I'm not an expert on energy, but it's true that in different activities on the project, we are touching upon this concept about inter-data space interoperability. For me, okay, you know better than me, but I think we have here 2 approaches. One is to define common ground. So let's say to define interoperability per design. So we just design the common ground for data spaces to be interoperable. But another approach is to design top-down. So based on the business cases, based on the real needs that those data spaces want to achieve, we can think of some kind of interoperability, you know, ad hoc interoperability. So define commonly semantic models that are aimed to solve these specific issues, instead of just considering a wide, let's say, bottom level, where by default, I think it's more difficult to achieve. It's true that it is ideal, but again, for me, data spaces are based on business cases or use cases. And on this regard, maybe it would be easier to start with specific use cases and where to achieve interoperability between energy and others, of course. So those 2 approaches, I think have to be considered also and combined if possible.
And then I would like, following this comment, I would like directly to follow up. I think one of the hottest discussion in energy is exactly related to what you just say. So what will be the first use case in which data space can make a difference? Do you have your personal opinion, or any other of the speakers an opinion where you see as this top winning use case to unlock the energy data space? Any proposal or idea? Yeah, Christoph, please.
Well, no proposal or idea, no specific one, because I'm not an expert for the energy domain, just occasionally working with experts like you. But to guide ourselves into thinking about what it could be, it is the advantage of data spaces becomes apparent when many actors exchange data. So a big number of actors exchanging heterogeneous data that they would not like to entrust to a central platform. And now to make it even more extreme, what also helps further is when at any time also additional participants might join the ecosystem. So participants that were not known before, and in which there is therefore no trust. Now the question is, what are such scenarios in the energy domain?
Well, see, Ferdinando would like to add something, so maybe.
Yes, thank you, Antonello. I think we have a real important scenario that is the flexibility market scenario, in which we had tried many approaches because we need the sharing data of many stakeholders, TSOs, DSOs, flexibility provider, customer data provided by the DSO. We tried different approaches like flexibility register concept, in which you can share data among the stakeholders. But I think the approach of the data space fits very well with this market approach. It's very, let's say, innovative in many countries in Europe, and we didn't solve it yet. With data space approach, we can solve many of the issues related to the data exchange for implementing the flexibility market in a standardized way across Europe, I think.
Yeah, I really agree with you. And let me add one point, also making my personal experience, because I'm transforming the energy system in my place, at my home, and I really stumble in big data roadblocks. My question in that respect is dual question, let's say. Do you think really can be data space something that will bring more people to be interested in being active? And second, do you see challenges in making people understand what we are discussing here? So I was wondering, is that something that we can reach the man on the street, or is data space a difficult concept to convey? What's your impression about it? Yeah, please, Sonia.
Yeah, I think it's definitely difficult. Also because sometimes also from our side, so the ones working on it and on research projects, we focus a lot on what's possible, and sometimes we forget about the value that that's going to bring to the users. So I think we have to make this exercise of thinking as a user that's going to benefit from what we develop. And sometimes we're like, yeah, we're achieving technical interoperability, and now I can send data from here to there, and now, yeah, I can understand the data and I can access this and that, and so, okay. But if you think about your user, what's going to be the user journey, and how is the user going to benefit from all these developments? So I think that's something that we're struggling when we only focus on what's technically possible. So yeah, I think we still have a long way to go also in defining the business models for what we do, and not the other way around. It's like I have a use case and I have to define a business model, and how do I make that happen from the technical perspective? And sometimes I think we work the other way around. It's like I have this setup, technical setup, let's find uses for this setup. And I think, yeah, changing the perspective would help.
Yeah, thank you. I think everybody would like to contribute. This is great. And maybe I just go on the way I see it on my screen. Ferdinando, please.
Yeah, I agree with what Sonia say. Let's say, I think one of the main issues is convince the people to understand what is the data space and the benefits of implementing a data space, more than technological issue. Because in the technological side, we can analyze and implement and find a way, define standardized mechanisms and so on. But if you don't convince the people about the benefits, it's very hard to implement the data space, because data space is made by the people, let's say. So I totally agree on that. So I think this is the main goal. So we need to facilitate, and what we have tried to do also in the project in which we collaborate is to explain the data space in a very easy way in order to be understandable by everyone. This is one of the goal that we are pursuing at more.
Thank you. Daniel, maybe you want to go next?
Yes, I want to emphasize that I think we have also faced similar challenges in the past. So because we have been working with data for many, many years, and probably we remember in the past that, and still here I live in Valencia, region in Spain. So here many, many companies do not see the real value for their own data. So again, we in the past already, already struggled to raise awareness of the companies, people, and so on, how valuable the data are. So just to acquire data, clean data, process data, analyze data, visualize data, and get value out of this data. But somehow we succeeded. So now companies are aware of the value of their data, so they are exploiting their data and making decisions based on their data. And now we're adding a new dimension, which is okay. And now you have you know how your data are valuable, but you have to share data with others. So we are adding a new dimension to this to this equation, which is more complex, but still I think it's quite similar to the past. So we have to evangelize the people or the companies now to provide okay. For me, the trust is key because okay, once you explain the concept of data sharing, which is quite simple, I would say. So you can share data with others and you get value out of this sharing data. So as long as there is a business model behind, it's fine, but you have to provide trust. And here I mentioned before, for instance, in the SBA, we have more than 100 hubs all around Europe. And I think the role of the hubs is quite important here because they have access to regional ecosystems. They have also infrastructures in place. They have also, they're in contact with the small actors in the regional domains. And the work here is key to evangelize people, to train people, to play small data spaces at regional domains and show people how the benefits of sharing data in data space are. So yeah, I think it's a new challenge, but we faced in the past, and we should rely also in regional initiatives to foster the adoption of these data spaces. But yeah, I agree with everything that's been said.
Thank you, Daniel. Christoph, you would like to add something?
Yes, well, another challenge to adoption and to understanding is the diversity and complexity of well, specifications and approaches and initiatives. So I think for especially for an outsider, a newcomer, it can be hard to find your way in. Let's say maybe you've seen a presentation by IDSA, to just give an example, and then you hear about Gaia X and you wonder, okay, what is the difference? Which one should I use? Or when you are already committed to one set of architectural principles, then you see multiple implementations. Like for Gaia X federation services, there are at least 3 technology stacks that implement them. So which one to use? And that's where the importance of overarching and bridging initiatives comes from. As Daniel, as you mentioned, the DSBA or the Data Space Support Center, with its glossary, for example, which tries to unify or to harmonize the terminology and the concepts, and aims at giving recommendations. Like, okay, when your scenario is this, then you should use that building block that was implemented by the following initiative.
Yeah, I think you touched a very interesting point that, if I remember correctly, specifically Sonia was discussing Brussels when we had one of the meeting of the cluster project, which is which connector is going to be and how many connectors are going to be part. What do you think, Sonia? Is this converging somehow in the which connectors and how to use connectors in a way that can be understandable? Because I think that's one key point probably on this interoperability question.
I think it's converging thanks to the data space protocol. So as long as the connectors implement the data space protocol, interoperability, technical interoperability should be ensured. Yeah, then we will have different connectors, because at the end you want to adapt the connector, as Ferdinando explained, for energy, then it will have certain features that other connectors don't have, so that's completely fine. But as long as they all implement the data space protocol, I think we will be good to go. Good.
But on top still there is the semantic issue, right? So we have, I think, as was mentioned in the presentation, strictly in electrical engineering, we have common information model as a foundation, but the challenge is many of the use cases like flexibility are bridging to other domains, and then becomes a little bit more difficult to reach common semantic. What's your opinion on the topic semantic interoperability?
Yes, that's of course, that's a different layer. So data space protocol will ensure the technical interoperability. For semantic, we have the need of establishing common information models and sector specific, but I would really let Christoph answer this question.
Please, Christoph, you want to add something on?
Well, there is not much to add, except so a lot of solutions are out there, but again, it is guidance with these solutions that is required. So, for example, like on independently from domains, the data space initiatives need to provide the right extension points for hooking in domain-specific semantics. So the mechanism that I hinted at, like using the keyword application profiles, and then there needs to be guidance on what ontologies, what vocabularies, what data and metadata schemas already exist. So for example, I think it was mentioned on one slide, like Saref as one ontology that is widely used in sensor and IoT applications, and that has already made its way through ETSI, so a standardization body, and so in any application in that area, one needs to build awareness that a standard way of talking about your data in a semantically interoperable way already exists, and that rather than inventing a new one, you should consider reusing an existing one, or if you have ideas of your own, like linking your concepts to the existing ones. And that again could be facilitated by the semantic aware metadata catalogs, or by the concept that IDS calls vocabulary hubs.
Yeah, I agree with you that this merging is one of the key elements, exactly because all the basically use cases that I'm aware of related to energy involve crossing domain, like e-mobility, for example. And then the merge of semantics is critical. And yeah, maybe you can rely on a sector in their own established, but then bridging is, and then linking from that perspective is really the key point. Daniel, would you like to add something?
Yeah, well, I'm not an expert on semantic interoperability. It's true that from what I see the different sectors have different contexts, and the context is important. It was mentioned by Ferdinando because they have introduced fireware broker context, which I think is important, but this is not an easy solution. But it was also mentioned by Christoph in his presentation, and we have also identified in our community that more and more the topic of how to use a large language model to facilitate semantic interoperability is gaining more and more relevance. And we really think that the AI could be used to solve, or at least to support solving some of the challenges, because large language model can also interpret semantics, can also provide answers, and also so somehow we can use also a large language model as a tool to support this semantic interoperability. I don't know what the rest of the colleagues think, but we think we should also start to use those tools for this type of challenges, I think.
Yeah, this is a good question to bounce back. What do you think about the role of AI in this challenge of interoperability? Will that be the solution? Is the large language models are the key ingredient we were missing? Any opinion on this topic? Or are they maybe not mature enough? So I've seen some concern that you're not sure what kind of answer you get anytime you ask the system question. I'm currently using this feature as a game in my teaching class. So I ask ChatGPT a question on a topic, and then I discuss with the student if he's right or wrong. And what is funny is that I try the exercise at home and I get a result. And then the following day I go to the class and I have to be ready. The ChatGPT will tell me totally different things, and I have to be ready to adapt my lecture live. So, any comment related to AI as instrument in this challenge?
You're right, Antonello. Maybe now it's not mature enough, but definitely I think we should consider as a support, at least for the.
I'm not against. I think it's definitely a great tool. My joke was just to yeah, put the challenges in stress, but I'm confident. I mean, the progress has been amazing in the recent time. That's what makes it really interesting. Christoph, you would like to add something on the topic?
Yes, I think an easy way of getting started with AI in data spaces is, okay, I mean, on the one hand, to distribute AI-driven data services through the infrastructure of data spaces. So thinking like from simple data exchange and simple services to more intelligent services, like me purchasing some products, like a piece of data here, a piece of software there, and putting it together with some AI and reselling the added value again back into the data space. That's the application perspective. But the data space infrastructure perspective is also interesting in, well, how can AI improve the operation of the data space itself? And there, well, I would not, as of today, I would not yet fully trust into AI to operate an entire data space. That's because some of the data that is exchanged is simply too sensitive. That's why we've established all these mechanisms to build trust. However, eventually AI might be able to do that because we need to remember where these trust mechanisms in data spaces come from. They are basically the machine executable re-implementation of legal or handshake-based agreements among humans. So things that have formerly been done on paper with signatures and stamps, they are now transferred to, well, to technology like cryptography and so on, and thus like checking whether I want to trust some other participant in a data space has become automatable. Or the Gaia X CTO, for example, likes to speak of compliance as code. And then, well, eventually you might want to give AI a try, asking questions. So can I trust that other participant and the data and services that other participant is offering? And if so, please explain to me why.
Yeah, I think the topic of trust has been also in a Q&A that is running in parallel. So there was a question on how is trust established between different actors who doesn't know each other? Is there a central authority, maybe a certificate authority, or the certificates P2P validated in a distributed way? And I've seen, so for those of you following, there is an answer given by Sonia and one from Christoph also. But then I would like to ask Ferdinando if in this discussion of trust, you see a role also for blockchain, given that you're a blockchain expert.
Yes, I think so, because the data space also can be enhanced by innovative technologies like blockchain. We had a very positive feedback from the partners that are using and testing the connector, asking for how to, let's say, enrich the trustness using blockchain. And we are ready for that. We are implementing this part into the Intersoft project, at least for the part of the transaction logging and data access management. I think that blockchain can enrich the trustness, because we introduce a new technology that is trustworthiness and secure by design. So you need to trust the technology. You don't need to trust the people. So we can ensure a high level of trustness inside the data space using blockchain technology. And we are doing this, and we have already some good feedback from the usage perspective.
Thank you. I have a new question on the Q&A, which says, why is data space component like the media data broker and the vocabulary hub optional requirement in the data connector report when there are key parts of semantic interoperability as regards the specification of self-description in those components? Will the mandatory identity and access management model have any connection to the interoperability layer? Somebody would like to answer? There will be this kind of a longish. Oh, but Christoph, okay.
Well, I could answer, but as it is, the terms, the question largely address IDS. Sonia, would you like to go first, and then I add something?
Okay, I can start. So regarding the components, we say the basic components, what would make a minimum viable data space is two connectors and identity management, so DAPS and CA, because that's the minimum requirement to share data. So you need to identify yourself, and then you can send and receive data, and that's it. According to your use case, the broker is normally highly recommended, but it's not 100% mandatory. That's because if you know the other participant, you can send data already. You don't need to go to the broker and see what datasets is available and what offering there is. Of course, depending on the use case, it's highly recommended. It might be mandatory. Same thing for the vocabulary hub. So the components may be required depending on the scenario, but the minimum, that the core components that every data space need to have are the connectors and identity management. And then second question, the identity management, yes, it has a connection. And also it's something we're checking now that we are addressing interoperability, inter-data space interoperability, what type of identity management and what type of certificates are accepted in every data space. And can I go with my certificate from data space A to data space B? Or am I going to have to apply a different mechanism for identity management? So for instance, am I going to have to use extra financial certificates, centralized identities in one, and then move? How do I do it if I move to another data space that's using decentralized identities? Is that possible? Can I still go in there, or do I have to apply other mechanisms? So yeah, that's one of the things that needs to be taken into consideration.
Thank you. Christoph, you would like to add something?
Yes, to add on the first part of the question and answer from my perspective. So I'm not officially speaking for any of the initiatives. I've just participated in various IDSA and GaiaX activities. And as much as I, as an expert for semantic metadata, would have liked metadata broker and vocabulary hub to be strictly mandatory, I can understand why they are not. Because to my understanding, the emphasis, or let's say the top priority in these data space initiatives is sovereign data exchange. So if I send you my sensitive data, I want to retain control over what you do with the data, and for that it is first and foremost necessary to have working like identity and trust mechanisms. Whereas indeed let's say the metadata broker could be understood as convenience. So like DNS on the web or on the internet. If I know a numeric IP address where I get my data or service from, I can type it into the browser rather than like a more human understandable name, or I don't need a search engine to find who is offering what when I know that already. But then when I know the one whose data or services I would consume, still the question is there not somebody else, like a malicious actor, trying to impersonate the one of whom I think that I know them? So that's why, to my naive understanding, identity and trust is slightly more important, whereas the other, like semantic interoperability elements, are well, convenience, but a very useful convenience.
Thank you. I see Ferdinando would like to add again also.
Yeah, I want only to enforce, let's say, the concept, because what we have, let's say, tested and evaluating during the OneNet project and the other projects is that we need to at least implement a basic concept of the data space, and the identity management, the access management are completely necessary, because all the people ask for identification of the actor, the participant, and the possibility to have the governance of the data, so the action and usage. This is the basic needs that any kind of participant asked for us when we implemented the data space. The vocabulary hub and the metadata broker or the catalog or whatever are important, can facilitate the creation of the data space, but at the moment for implementing the basic version, let me say, is not mandatory. So I think when the data space concept will be consolidated and most used, more used by the people. I think also the vocabulary and the metadata broker will be convergent, let's say, in the mandatory part of the data space when all the people will use it.
Thank you. So we are a few minutes away from the schedule, and maybe I would like to close with a final question, again, open to all of you. So I remember, I think directly I think from Daniel's presentation, if I'm not mistaken, there was already a timeline, but what do you think will be in the timeline, I mean, when the next big step in the application of data space? So we have this cluster of projects. They are 1 year roughly through, so they have still 2 years to go. What is coming next in your view, and what could be the next big step for data space and for their impact particularly? Anything you would like to stress? Please, Daniel.
Well, I don't know which is the next steps, but in my opinion, for sure, it has to be driven by business models and use cases, definitely. So I think we have all the components that have been presented by IDSA, Gaia-X, Fireware. So I think we have all the blocks and so on. But I think we need to show the value for specific use cases. And those use cases and business models come from the industry or for society, but by specific challenges and problems. So as long as we can identify those problems and provide value with data space, it's fine. Because for me, data spaces are not the end, are the means to provide this value. So also answering the previous question, I will try to be flexible on that. So as long as we solve the problem, it's fine. I mean, I wouldn't expect that to be compliant with this and that. We have to implement some blocks, but again, for me, it's flexibility to solve challenges. So if we want to unleash the full potential of data in Europe, we need data spaces for sure, but we need also use cases and business. At the end, for me, in the future, for me, I think data sharing will be seen as a commodity, as we have to the internet. Someone also, I think it was Christoph, mentioned before the internet. So at the end, if we can see data sharing, data spaces as a commodity, so very transparent way, I think we will have achieved our goals. So this is my view for the future, at least.
Thank you. Very good. Sonia?
Yes, I totally agree that we have to focus on the value that data spaces bring to citizens, to companies. I would add that we need to continue working on the technology to make it mature enough. So working on this seamless interoperability, connecting different data spaces, this cross-domain interoperability. So this is the means that we have to work on. And I would add also the communication. So communicating the value of data spaces. So making sure the relevant stakeholders understand the value. And I think we will be able to communicate that when we have clear business models or use cases.
Thank you. Christoph.
Yeah, one thing that I'm looking forward to happening, hopefully in the next few years, is the interoperability across data spaces. So because in history, like looking a few years back, for example, at what are now the Gaia-X Lighthouse projects, or in IDS, those participants that are operating IDS ready certified components. A few years ago, all that was like, these were good intentions announced on PowerPoint slides. Now each of these initiatives is operational in itself on its own, like making real serious use of implementations of data space specifications. However, not yet, at least not largely in a fully conforming way. It is good enough to solve the application, the application scenario of that specific initiative. To mention one example is Catena-X for the automotive supply chain. This is one of the first lighthouse projects of Gaia-X. But then the true challenge is when one of these data spaces starts to talk to other data spaces, like when services that are useful in one data space, when they become requested by consumers from other data spaces, or from the provider perspective, when I as a provider, when I'm running already a successful business in one data space that I would like to offer that service to extend my business into other, say, other domains. And that now technically that will only work when I'm fully conforming to the standard and not only claiming so for marketing or political reasons, which is largely the today's situation. But I think this phase will also be over soon.
Thank you very much for all your contribution and a very active discussion. We reached the 5 o'clock, so I keep the promise and close the meeting on time, because I'm pretty sure all of you have some follow-up activities, work or not work related, doesn't matter. Time is critical. Thank you so much. I think this was an incredible insight in one meeting. Having such relevant speakers together has been really a great value. So as president of the FEIN, I really thank you that our meeting was so important, and we'll make the recording available. I'm sure we get a lot of people interested, because this is really something unique. I can tell you, I was probably many data space discussion. I think was very concrete. Thank you so much. It was a great pleasure interacting with all of you, and thank you for. You definitely deliver a value. That's what we've been discussing. For me today, the value was there, no question. Have a nice evening, everybody. And I'm sure we'll meet soon somewhere talking about data space in a different context.
Thanks
Thank you so much. Have a nice evening.
Have a nice evening.
Thank you.
Thank you. Thank you all. Bye-bye.
Bye bye.
Bye.
Thanks so much. I'll stop the recording now.